This is lesson 4.1a. We're going to determine if a number makes an equation true or not. So I just want to give us one quick example of a basic equation. So an equation could be 4 plus 2 equals 6. And equations are really just balanced math sentences. 4 plus 2 equals 6. Well, is this true? Yes, it's true because 4 plus 2 is 6, and 6 is equal to 6. So when we think about equations are just math sentences. And if I draw a dotted line where my equal sign is, that separates the left side of the equation from the right side of the equation. So when we think about equations, we have to think about keeping the left side and the right side balanced. And that information is going to help us to determine whether an equation is balanced, whether the equation is true. So if we look at example 1 here, it says that we're going to determine whether a value is a solution of an equation. So the word problem says, Jordan received a $15 gift card for phone apps. He has used $4.50 of the value and wants to buy one more app to use up the balance. Which app should Jordan buy? So they say we're going to model this with math. They want us to use a bar diagram. So if you don't remember, a bar diagram means we're going to draw a rectangle. And in your notebook, you should have already written 4.1a. And we're going to have to represent this word problem on the bar diagram. So the first thing I like to figure out here is what is the total amount? What is the total amount that Jordan has on a gift card? Well, it says Jordan has received $15 on his gift card. So that means that this whole rectangle is going to represent $15. He has used $4.50 of the value on one app, and then he wants to use the rest of the money to buy another app. So we are going to divide this box into two parts because he's already spent $4.50 on one app, and then he's going to spend some other unknown amount on another app, and both of those are going to total and equal $15. So now I represented that other unknown amount with a variable with the letter X because I can use any letter to represent an unknown number. So now we're going to write an addition sentence here. We have $4.50 plus the cost of X, and we want that to add up and equal $15. Okay, so they gave us 3 apps over here. The recipes phone app will cost $9.50. The sports app will cost $10.50, and the remote desktop is going to cost $12. So we are going to use each of those amounts and set that equal to X. So really they're saying X could equal $9.50, X can equal $10.50, or X can equal $12. Okay, so we're going to be plugging in that value for X into the equation. So in your notebook, I want you to write this equation. $4.50 plus X equals $15 when X equals $9.50. So they gave us a value for X here. We're going to take that value and plug it in. Anywhere we see an X, we are going to plug in $9.50. So we will have $4.50 plus $9.50. And we're saying, does that equal 15? I'm going to put a little question mark up there above the equal sign because I'm not sure yet if this is going to equal $15. That's what we're figuring out. So will the left side equal $15? So let's plug it into our calculator. $4.50 plus $9.50. So 4.5 plus 9.5 equals $14. So is 14 equal to 15? No, it's not. So he would have $1 left over. That's not what he wants to do. He wants to use up all of his money. Okay, so now let's try if x equals $10.50. So in your notebook, we're going to rewrite the same equation again. You're showing all this work. $4.50 plus x is going to equal $15. And now we're saying, well, will x equal $10.50? So I take that value for x. I'm going to plug it in. $4.50 plus $10.50. Will that, it's a question, will that equal $15? Well, let's put it in our calculator. 4.5 plus 10.5 is 15. So 15 equals 15. So that means that he can buy that sports app for $10.50 and use up all of the money on his gift card. And before moving on to a new question, I just want us to look at some of the definitions they give us here. So they say an equation is a mathematical sentence that uses an equal to sign to show that two expressions are equal. So my example before, 4 plus 2 and 6. Well, this is an expression and this is an expression. So it is now an equation because it is showing that that left side and the right side, both of those expressions are equal. And then the second definition says that a solution of an equation is a value for the variable that makes the equation true. So when we said that x equals $10.50, that was a solution. It's the value that makes the equation true. Okay, so now let's try an example. We're going to try number 5. So in your notebook, you should be writing number 5. On our equation, d plus 9 equals 35. And then they give us 4 values for d over here. They say that d can equal 16, and then it's separated by a comma. That comma just tells us that d can also equal 22, d can equal 26, or d can equal 36. So that information can really also just be written like this, where we say that d equals 16, d equals 22, d equals 26, or d equals 36. So we're going to take that first value, d equals 16, and plug it in. So anywhere we see a d, I'm going to write 16. So we would have 16 plus 9 equals 35. I should see this work in your notebook. So now we're going to evaluate the left side of this equation. Well, what's 16 plus 9? 16 plus 9 is 25. So we're saying, is 16 plus 9 35? Well, 25. Is 25 35? Nope. So D does not equal 16. Let's try the next example. D equals 22. So you're going to plug that in. 22 plus 9 equals 35. So now we evaluate the left side of the equation. What's 22 plus 9? 22 plus 9 is 31. So is 31 equal to 35? No, it's not. And I draw a line through that equal sign because that's telling us that it is not equal. So D is not equal to 22. Okay, now I want you to try D equals 26. So plug that in your notebook. 26 plus 9 equals 35. And notice that we're still just using that original equation up here. D plus 9 equals 35. So now, what's 26 plus 9? 26 plus 9 is 35. Is 35 equal to 35? Yes, it is. So check. D equals 26. And obviously, D equals 36 is not going to be an answer because we would have 36 plus 9. Will that equal 35? Well, what will the left side of the equation equal? That will equal 45. So 45 is not equal to 35. Let's do one last example. Number 6. So for number 6, we have 14n equals 35 when n equals 2, n equals 3, n equals 3.5, or n equals 4. So your first step is going to be to plug in. We would have 14. What does it mean when we have a number and a variable right next to each other? Like 14n here or 14 with the 2 in parentheses? It means multiplication. So is 14 times 2 equal to 35? Well, 14 times 2 is 28. So does that equal 35? No, it does not. Okay, so n equals 2 does not work. I want you to now try with n equals 3, n equals 3.5, and n equals 4. And I want you to tell me which is the solution to this expression. When you plug in the value for n, which one will equal 35? So if I plug in 14 times 3, does that equal 35? 14 times 3 is, hold on, 14 times 3 is 42. So nope. 14 times 3.5. Does that equal 35? I can already say nope, because when I did times 3, it was too big, so we get 49. Does not equal 35. And then 14 times 4. Does that equal 35? It's 56. So nope. Does not equal 35. So our answer here is that there is no solution. I didn't realize that was going to happen, but it can. There was no solution here. And later in this topic, we will be able to figure out what n equals.